Thank you. Good afternoon, sir.
Good afternoon.
It's my great privilege to welcome our resource person, Dr. J. Somasekar, sir, with the topic Machine Learning for Recommendation Systems in E-commerce and Streaming. Dr. J. Somasekar, sir, received his MTech degree from the National Institute of Technology, Karnataka, NITK, Surathkal in 2010 and PhD degree in Computer Science and Engineering from JNTUA in 2017. He is currently working as a professor and HOD at the CSE Department, Gopalan College of Engineering and Management, Bangalore. As a resource person, keynote speaker, he has delivered 130 technical talks in 12 states of the country. He got All India rank of 43 in the GATE exam. He has 16 years of experience in teaching and 6 years of experience in research. He has published 23 research articles in leading journals and conference proceedings and 2 international textbook chapters. He also received Innovative Collaborative Research Award in Medical Imaging for research collaboration with Dr. Cheng Ho, ITRI, Taiwan. His current research interests include image processing, machine learning, big data analytics, and ML for cybersecurity. Thank you, sir. Now I am handovering the session to Dr. J. Somasekar, sir.
Yeah, thank you, sir. Just I'm sharing my screen, sir.
Yes, please.
So whether my screen is visible, sir?
Yes, sir, visible, sir.
Yes.
So thank you for the introduction, sir. So, good afternoon, all the participants. So coming to the my session in 1 week national level FDP. So machine learning for recommendation system in e-commerce and streaming services. So I'm going to explain what is recommendation system and how machine learning plays a vital role for recommendation system in e-commerce applications and streaming services. Of course, other applications also I will list out, and based on that, we can understand the significance of recommendation system in day-to-day life, and all those things I'll explain in today's session. Even though we have 45 minutes a session, I'll try to explore more about recommender system. Maybe I will provide some of the resources. Based on that, you can explore more about recommendation system with hands-on also. So before going to the agenda of today's session, so just I will explain briefly about recommendation system. After that, I will move to the agenda of today's session. So as you can see here, you can see, let us assume here YouTube and Netflix, Prime Video. These are all comes under streaming services, and of course OTT platforms, Prime Video, Netflix, and Amazon, and we have Telugu OTT platform AHA. Like that, we have streaming services, and we have a few more e-commerce websites like Amazon, Flipkart, or eBay. These are all streaming, e-commerce websites, and we have social media. Facebook, LinkedIn, etc. And also we have music websites. Here you can see YouTube Music, etc. We have so many music also. So like that, when you take, these are the various applications of recommendation system in which every day we are getting recommendation of some movies in YouTube or maybe Amazon Prime. So because of pandemic, so I think everyone knows about OTT platforms, Prime Video or Netflix or maybe Sun Next, etc. Whenever if you open these OTT platforms, you'll get recommendation of some videos or maybe some movies or maybe some comedy videos, etc. Or whenever if you open YouTube, you'll get recommendation of some videos. Or whenever if you go for e-commerce website like Amazon or eBay, etc., Flipkart, etc., you will get recommendation of the products, or maybe recommendation of the textbooks, or recommendation of the mobiles, etc. Or whenever if you go for LinkedIn, Facebook, you will get recommendation of the friends. When you open Face, the following friends are recommending for you or suggested for you. Or whenever if I go for LinkedIn, there also will get recommendation of the friends, or maybe recommendation to connect some of the people those are related to your profile. So now the question is exactly what is happening beyond this. So every day we are being influenced with this recommendation. So from 1 year kid to maybe 56 years persons, we are being influenced with this recommendation. influence with any people, any father or mother, etc. Directly they are downloading. How it possible? What is exactly happening? So that I'm going to explain in today's session. So exactly what is recommendation system, and based on this recommendation system, as a customer or as a user, what benefits we are getting. At the same time, as a owner of maybe e-commerce websites or streaming services, what benefits they are also getting. Obviously, they are also looking for benefit. We can call it as a revenue. We are also getting benefit. We can call it as some sophistication or maybe some easy way to get the items. So that type of benefits we are also. Finally, the customer or user should be happy. So for that, recommendation system comes to the picture. We have huge number of applications. So yesterday, one of the session, sir explained about a recommendation system is one of the application of machine learning. So almost that is continuation of that session, this one today. So almost I will explain all the recommendation systems types and what are the use cases or case study and what are the models, and I will take one of the for recommendation system. So all those things I'm going to explain in today's session. And you can see the value of recommendation. Suppose if you take Netflix, so 75% of the movies or maybe videos are watching because of this recommendation. Whenever if you go for Netflix OTT, of the users or customers watching videos because of this recommendation. So obviously they will get huge revenue. That also I'll come to the later. And Amazon, so they are getting 35% of the revenue generated because of this recommendation system. So whatever revenue they are getting, that revenue increased 35% because of this recommendation. That's why nowadays there is a huge demand for recommendation system research also. So research also it's going on, not that much increasable research, limited papers. If you search in Google also, we can't find vast number of research articles, but we can find only limited articles, and still research is going on. At the same time, streaming services, e-commerce owners still looking for better recommendation. Based on that, they can generate huge revenue because of this recommendation. So which indicates the value of recommendation for Netflix, Amazon. Just I'm showing one e-commerce website, one streaming services or OTT platform. Like that, if you take other OTT platforms or maybe other streaming services, maybe other applications, so they are also getting huge revenue because of this recommendation. So that means every day we are being influenced with this recommendation system. Because of that reason, we are also happy. At the same time, the owners of the e-commerce websites or maybe streaming services, they are also getting huge revenue. This is one of the statistics. It shows that how much revenue they are getting because of this recommendation. At the same time, research is going on this recommendation system. Maybe if anyone will participants, I request you to mute your voice. Yeah. So because of that reason, they are also getting huge revenue. So with this short introduction, now I will move to the agenda. Of course, here value of recommendation. YouTube also we have 60% of the clicks based on the recommendation. So even Google Play, 40% of the apps installs comes from recommendation, because I already said. So kids also 4 years, 5 years kids also, they are downloading some of the apps. By means they'll get recommendation. Simply they will click that one, automatically it will download. So that much influence even for kids also showing off this recommendation system. So with this brief introduction, recommendation system, what are the types of recommendation system, what type of machine learning model will plays a vital role for recommending these items or movies to the customers, and that also I'm going to explain. And with case study, I will show one of the data set, a movie data set or maybe healthcare data set, and I will show how actual recommendation system will recommend the movies or maybe products or maybe drugs to the customers. That I will show, so that you can understand exactly what is happening in the recommendation system and how the machine learning comes to the picture. Now, with this brief introduction, now I will move to the agenda of today's session. So that's why I'm showing all the images, so that you will get idea about recommendation system. Every day we are being influenced. Now we'll come to the agenda. So first I'll explain what is recommendation system. So the basic theoretical definition followed by graphical representation, so that you can understand what is recommendation system. And what are the applications of recommendation system? So we have huge number of applications of recommendation system. I will list all the applications. Maybe we will take 1 or 2 applications for case study for better understanding how the recommendation happens. And types of recommendation system. We have different types of recommendation system. So we will go for one type of recommendation system, that is the scope, that I will explain what is the type we are going to consider in our session. And I will take one simple measure for recommendation system, that is simple mathematical measure, that is called Pearson correlation coefficient. Of course, we have other measure, I mean other models also, like matrix factorization, or we can call it as a latent factorization, a Bayesian classifier, or a Navi based classifier, or maybe we can go for a cosine similarity. Like that, we have so many machine learning models are available for recommendation of the items or products to the customers by using that algorithms. But I'm going to take one simple mathematical or statistical measure, that is called PCC. By using that, how the recommendation system works, based on that, how we have to recommend the products or maybe movies to the customers. With the case study, I will explain. And if time permits, so we'll go for evaluation measure followed by small quiz. Of course, participants can easily answer that quiz also. You can only answer this movies will recommend to this customer, or this products will recommend to this customer. Like that, you can easily analyze, and based on that, you can answer the quiz also. But we will see, we'll try to see that also evaluation measure, because whenever if I go for machine learning, so we have main three steps. One is pre-processing, that is very, very important. And after that, model, selection of model, whatever it may be. After that, evaluation. Of course, we can deploy after that based on the performance. So that's why evaluation was, without evaluation, we can't decide which model is the best for the given application. It may be recommendation system, or it may be healthcare application, or it may be XYZ application. So that's why evaluation also very, very important. So that's why if time permits, I will show which evaluation measure we are going to apply for recommendation system. Based on that, you can understand the significance of evaluation measure for recommendation system. And also I will show some of the resources, because whatever I'm going to explain, just I will show the path, because we don't have that much time. In general, recommendation system only I used to take 3 hours by taking all the models of machine learning, but we don't have that much time to explain all those things. Because of that reason, I will show some of the resources. If you are really interested for further research, or maybe further studies of recommendation system, you can use that resources. Based on that, you can go ahead for further exploring or maybe enhancement of the recommendation system. So this is a brief agenda. Almost I'm going to show complete path of this recommendation system with some of the case studies followed by evaluation. Now, I'm not going to explain machine learning definitions, types of machine learning, all those things, because almost all the resource persons already done. Again, no need to take definitions, all those things, because it will bore, obviously. So now I'll directly move to the recommendation system. So when you come to the recommendation system, now we are in big data era, because whenever if I take any organization or industry or maybe universities, etc., we have a big data. We have everywhere big data. That's why machine learning, data science, all those things comes to the picture. So, but when you come to, when you have a big data, as a user, as a customer, it is difficult to select some of the items or maybe some of the products. Maybe it will take long time, or it is difficult to search also. That's where recommendation comes to the picture. So basically, the recommendation system will identify the user requirement, maybe user taste. Based on that, it will recommend movies or maybe products. But the question is how it will identify, in what basis, what are the different types of recommendation. All those things comes to the picture. Based on that, we can see exactly what is recommendation system. So here you can see simple graphical representation. Based on that, you can understand. So this is the movie database. Let us assume I'm taking streaming services, or maybe you can take it as e-commerce application also fine. So it is I'm taking here not generic, specific to movie. So these are all movies. Let us assume we have comedy movies, or maybe action oriented movie, or maybe a romantic movie, or maybe thriller movie, etc. We have various genres, we can call it as a, or maybe various categories of movies. So here, this is my interest. So this is I used to watch only comedy movies. This is my interest. So what this recommendation system will do, it will filter these are the movies which I'm not showing interest, so it will recommend only comedy movies. So this is the recommendation to the customers or users. So this is a basic simple structure of recommendation system. The recommendation system basically information filtering system, and it will recommend movies or products to the customer based on the interest, or maybe based on the similarity. Like that, we have so many other constraints. So just I'm giving simple way to understand the recommendation system. So these are the things. Maybe these are all action, maybe romantic, or maybe thriller, or maybe other kind of category of movies. This I'm not showing interest. That's why it will filter. It will recommend only these comedy movies to the customer or user. So this is a simple definition. Similarly, we can apply to the, let us assume, products. So these are the products, maybe mobiles or maybe some fridge or maybe some other items. So I'm showing only interest on mobile. Then what recommendation system will do? It will recommend all types of mobiles to the customer or user. These are the things which I'm not showing interest. That's why it won't recommend. Or maybe here we have various types of textbooks, maybe C program, C++, data structure, history, economics, like that. But I'm showing only, let us assume, programming textbooks. What happens, this recommendation system, it will recommend only programming related textbook, maybe C, C++, Java, maybe Python, or programming, maybe Skylab, etc. These programming related textbook only it will recommend. So this is a basic idea in the recommendation system. So it will look for the interest of the customer or maybe similarity. Based on that, it will recommend to the customer. Obviously, we are also happy. Now the question is whether we are going to give order, whether we are going to watch, that is left to you. So the recommendation system intention or objective is to recommend whether the customer or user are going to watch, or whether the customer or user are going to buy that whatever recommendation you are getting, that is left to the customer. So that's why I have informed already in the previous slide. When you take YouTube, so maybe out of 100 videos, 60% of the customers are watching movies or maybe videos or whatever recommendation he is receiving. But it's not guarantee all 100% recommendation going to happen in YouTube also. So that's why the objective of the recommendation system is it will recommend whether the customer or user going to watch or not, left to the customer. But as per the statistics in Netflix, 75% of the users are watching movies because of this recommendation. Now, when you see the applications of recommendation, we have huge number of applications, whatever domain or maybe whatever field, if we take, we have application of recommendation. Suppose if we take streaming services, Netflix, YouTube, Amazon Prime, Disney Plus, Hotstar, etc. So we have a recommendation system application, the recommendation of the movies. E-commerce, I already discussed. So recommendation of the products or books or materials, whatever it may be. So e-commerce websites, we know Flipkart, Amazon Prime, Amazon, and eBay. These are all e-commerce websites. There you will get recommendation whenever if you open. And healthcare medical industry, I will show one of the case study for this healthcare medical industry. So how the drugs means your tablets will recommend to the customer or user, how the doctors or maybe specialists will recommend to the customers. So how the recommendation system plays a vital role. I will show some of the research directions also. If really interesting for further research, I will show some of the research publications. There you can identify exactly the significance of this recommendation system in healthcare or medical industry. And finance and agriculture sector. So in finance also, what type of policies? Whenever if we open mobile, sometimes we'll get messages. So this policies, LIC policy is recommending to you based on your profile. Or maybe when you go to the bank, or maybe when you have a bank login credentials, when you open the login credentials, you will get some of the policies recommendation. So this EMI may very less, or maybe this rate of interest is very less, we can take this policy. Like that, we'll get some of the recommendation of the policies. Even agriculture sector also, we have huge number of applications of recommendation system. So what type of pesticides we have to use, or what type of crop we have to use, depends on the nature of the soil, etc. We have huge applications of agriculture sector. So just in agriculture sector, recently I have handled session for this recommendation system 3 hours. So that many applications we have in agriculture sector. Even you can type in Google recommendation system for agriculture, you can find huge number of case studies and applications and publications. Based on that, you can go through that, you can identify exactly the applications. And social media, Facebook also, whenever if you open, you will get the following friends suggested for you, or the following friend is suggesting for you. Whether you are going to accept that friend request or not, or whether you are going to send friend request or not, that is left to you. But the recommendation system will recommend the friend suggestions. Even if you take LinkedIn also. Even when you go for hotels, tourism, library, e-government, even jobs websites also. Whenever if you take jobs websites, or one of the simple example, LinkedIn. So you have a profile. Based on your profile, you will get some of the recommendation of the jobs. So this job is recommending to you based on your profile. Or maybe if you go for other jobs profiles, maybe there also you'll get based on your profile recommendation of the jobs. Like that, we have huge number of applications of this recommendation, and there is a huge research is going on. Maybe if you are interested, you can choose this topic for your research also. Even acceptance ratio also very good, because there is a huge number of applications. Maybe if you take one model, machine learning model, you can say XYZ model for recommendation system in streaming services. Now same model, you can take one more application, just you can change the data set. That is the advantage, that is the beauty of this machine learning models. Whatever model if you we take, you can do some fine tuning and apply to the other data set that is suitable to the application. That means if you make one model, we can apply in recommendation system only more than 10 papers easily. So if the accuracy is very good when compared to the previous research, obviously there is acceptance is very high in good journals like Elsevier or Springer or maybe any Scopus indexed journals also. Now, when you come to the types of recommendation system, I think hope you understood what is recommendation system. It is basically information filtering system, and it will recommend the products or movies to the customers based on their interest, maybe based on the similarity of the others. Still, we don't know what is similarity, all those things. I'll come to the similarity measures, all those things later. Now, when we come to the recommendation types, so we have popularity based recommendation and content based recommendation and collaborative filtering or collaborative filtering process of recommendation. Popularity based means it will recommend based on the popularity. So that is called trending. Suppose yesterday some movie trailer released, let us assume yesterday some movie trailer released, let us assume Bahubali, let us assume. So this is a more trending video, automatically it will recommend to all the users, all the customers. That is called popularity based or popular based. So that is the trending. So based on the trending, automatically whenever if some new teasers or maybe trailers are released, maybe Telugu or any other language, automatically will get recommendation because that is the most trending video like that. Maybe you can see in YouTube also trending #1, trending #2 like that. Such type of videos will get automatically recommendation. That is called popular based recommendation. Now content based, I'll explain in detail what is content based filtering and what is collaborative filtering. So we are going to focus in our session collaborative filtering process. Based on that, how we are getting recommendation of the movies or products. So content based also I'll explain. I will show the difference between these two so that we can understand. But popular based means understood that more trending video or maybe product based on that will get recommendation. Especially if you take iPhones also, any new model released automatically get recommendation of that iPhone in your e-commerce websites. Now I'm going to focus more on collaborative filtering process for recommendation. So first we will see the difference between content-based filtering and collaborative filtering for recommendation of the items or products to the customers. I'm assuming two users, user A and user B, and both watched the movies Crack and KGF. So user A also watched movie Crack and KGF, and user B also watched Crack and KGF. So what it indicates? So it indicates the similarity. So both you maybe like much about this action-oriented movie. Crack also action movie. KGF chapter 1 or chapter 2 action movie. That indicates that both used to watch action movies. That means both are similar users. Let us assume A watched the movie Bahubali. So she watched the movie Bahubali. What the recommendation system will do, because based on the history or maybe based on the data set, A and B are similar users. So whenever the user A watched the movie Bahubali, the recommendation system, what it will do, it will recommend to B. So this is called collaborative filtering process. So whenever A and B are similar users, both watched the movies Crack and KGF. When A watched the movie Bahubali, then automatically it will recommend to B because both are similar users. Suppose if B watched the movie, let us assume Kantara, let us assume recent sensational movie Kantara, then automatically this movie also will recommend to A. So because both are similar users. So this is the collaborative filtering process in which the recommendation system looks for similarity between users. Based on that, it will recommend it. So when you have a huge data sets, so they are using collaborative filtering techniques, especially when you take movie data sets or when you take product data sets, etc. So they are using collaborative filtering process. There we are looking for similarity. Based on that, it will recommend products or maybe movies to the customer. I hope understood the clearly what is collaborative filtering process. Just we are looking for similarity. That is the main thing. Of course, when you come to the models, how we are going to apply all those things, I'll explain. Now coming to the next one, content based. So we know popular based or popularity based on the trending will get recommendation, and collaborative filtering process will get recommendation based on the similarity. And when you come to the content based filtering, so let us assume user A watched the movies. Movie 1 is comedy genre or maybe comedy category. Whenever if you open OTT platform, you can find like the comedy genre or maybe action or maybe thriller or maybe romantic like that. So you used to watch only comedy movies. You watched so far 2 movies and comedy movie. And let us assume Today, these three movies released because every day huge number of movies released in the OTT platforms. Let us assume these three movies released in the OTT platform. It may be Amazon Prime or Netflix or AHA Telugu channel or maybe Sun Hotstar or maybe Sun Next, whatever it may be, OTT platform streaming services. So these are the three movies released. Now, based on the past history or profile of the customer, so he used to watch only comedy movie. What the recommendation system will do, it will recommend movie 4 instead of recommending movie 3 and movie 5. Movie 4 will recommend to A because he used to watch comedy movies. That's why movie 4 will recommend to the customer. So that means here, based on the past activity, the recommendation system will recommend movies or products to the customer. So this is called content-based filtering. In content-based filtering, so it looks for past activity or profile based on that. Again, you'll get doubt. Suppose if there is no profile, in what basis it will recommend. So that is called cold start problem. So cold start problem. We have so many issues also. I'm not telling we are fine with the recommendation system, whatever existing. We have so many issues also. That's why still research is going on and there's no end for research also. So maybe you can take this type of issues. So cold start problem, there is no profile. Suppose so far I did not watch any movie, then in what basis the recommendation system will recommend movies? This type of issues are there, but still research is going on. Maybe if you type the issues in recommendation system, you can find so many issues also. One issue is one research you can take. So this is called content-based filtering. I hope three types of recommendation system clear. Now, if you take one more simple example for e-commerce website. So user A, she used to watch only, let us assume, beauty products always. So whenever new beauty products released in the market, then automatically that products will recommend to her. So there is no similarity here because she used to buy only, let us assume, some Fair and Lovely or maybe powder, etc. beauty products. Whenever beauty products are released in the market, new beauty products, automatically it will recommend to user A. Why? Because past activity of this user is beauty products. Because of that reason, it will recommend. Or maybe let us assume I used to shop so far only programming languages. Let us assume textbook C, C++, etc. Then whenever some new textbooks with the new authors released in the market like Python programming or maybe R programming, etc., then automatically I'll get recommendation because based on my profile. So I used to buy only programming languages because of that reason. So whichever programming language textbook released in the market, I will get automatically recommendation. So this is called content-based recommendation. So finally, popularity-based means based on the popularity or trending video will get recommendation. Collaborative filtering process means based on the similarity will get recommendation. Content-based means based on the past activity or based on the user profile we get recommendation. So in our session, I'm going to consider collaborative filtering process. So based on the similarity, how the recommendation system will recommend movies or maybe products to the customer. So that is the main scope of our session. Of course, content-based popularity, that if you are interested, we can go ahead with that later also. So I'm going to consider collaborative filtering process for recommendation system because here you can see the rating based on the rating system and how it will recommend movies or products to the customers. So I will show one case study. Based on that, you can understand in detail how the collaborative filtering process will help to recommend movies or products to the customers with one of the machine learning model. So this is the movie data set I have downloaded from grouplens.org. Suppose if you are looking for data set, you can go through this website. Or UCI machine learning repository, also one of the best repository for downloading benchmark data sets. You can, or maybe any other public repositories like Kaggle, GitHub also you can use. But the data set what I'm using, I downloaded from this website. And the data set looks like this. So here we have user ID or username, movie ID or movie name, a rating given by the user and timestamp. So the movie data set looks like this. So user IDs, movie IDs, rating, and whatever rating here, let us assume here all 4.54 like that. That means rating scale is 1 to 5 considered here. And whenever if you have a data set, so we have to make it as a utility matrix. This is called pre-processing, or we can call it as user item matrix. So rows are users or customers, columns are nothing but items or products or movies, whatever it may be, depends on the application. So the rating given by user 1 to item 1, 5. You can see the data set. Here user 1 to item 1 rating is 5, user 2 to item 1 rating is 4. So here like this. So I think rest of the ratings are not available. Leave it, not an issue. And here all the ratings are available for user 2 to all the 4 items, and user 3 to user item 3, item 4 ratings are available from the data set. That's why I make it as 4, 1, etc. Like that, we can make it as a DDT matrix, because directly I can't impute the data set. That's why we have to do some pre-processing in which we have to convert it into matrix. After that, we'll go for further steps. So this is called utility matrix, or we can call it as a user item matrix. So the basic idea beyond this recommendation system in collaborative filtering. So as you can see here, some of the matrix elements are missing. That means ratings are missing. That means user 1 not given any rating for item 2, as well as user 1 has not given any rating to item 3, etc. That means maybe he did not buy these items. That's the meaning here. Now what we have to do as per the recommendation system, the recommendation system will predict the rating. So wherever empty cells are available, this rating we have to predict. That means the recommendation system will predict this rating. Based on that, it will recommend. Based on that, the system will decide, the recommendation system will decide whether the items are going to recommend to user or not. So that is the basic idea. So here you can see the objective of the recommendation system. Here you can see, let us assume, so these are all empty cells. Let us assume what we have to do, we have to find the rating prediction. So after that, it will recommend the movies or maybe products to the customer based on the rating. So maybe 1 to 5 rating scale, if we take, maybe rating is 4 or 5, then it will recommend. Maybe 1 to 3 rating, maybe let us assume poor rating, it won't recommend. Like that. That is the basic idea beyond this. So we have a user item matrix. After that, we have to apply one of the machine learning model. It may be Bayesian classifier, it may be KNN, or it may be decision tree, or it may be random forest, or it may be any statistical measures like Pearson correlation coefficient, or maybe cosine similarity, or maybe matrix factorization method, whatever it may be model if we take. So you have to apply. Based on that, we can find the rating prediction, followed by recommendation of the movies or items to the customers. So maybe once if we've done the rating prediction, let us assume the rating prediction is 4, then it will recommend. Rating prediction is 5, it will recommend. I'm taking rating scale is 1 to 5. Suppose if the rating prediction is 1, 2, 3, let us assume, maybe the recommendation system won't recommend because the minimum threshold value is 4 for recommendation, let us assume. Or if you want to fix as a developer, if you fix rating is minimum 3, then whenever if the rating prediction is 3, then it will recommend. Otherwise, as per my intention, or maybe as per my threshold value 4, that's why 4, 5 rating prediction is it will recommend the products or movies. Otherwise, it won't recommend. So this is the basic idea. This is the main object behind this recommendation system. So, but we have to apply various machine learning model. Based on that only we can go for rating prediction. So here I will show one simple statistical measure by using that how the recommendation system will work and how it will recommend. So that is called Pearson correlation coefficient. So the base paper for this is, so improve collaborative filtering recommendation through similarity prediction. This is the base paper I have considered for this case study. Maybe if you go through this paper, you can, this is published in 2020 in IEEE Access. If you go through this paper, you can find complete information about this collaborative filtering by using this PCC. So you can see the formula also. You can see formula. I will explain this formula. Don't worry. Here so many, because in general IEEE formulas or maybe notations difficult to understand. But I will show simple notation. This we studied, I think 10th class or 9th class. Maybe in best case 10th or 9th class. Maybe worst case engineering first or second year in statistics we studied. So that is called correlation coefficient. How to measure the correlation between two random variables in statistics? We call it as a correlation coefficient. By using that, we have to go for measure between two variables correlation. So these are the concepts. I will explain this. What is the meaning here? What paper? So this is a simple formula. Here the basic idea is, let us assume X is one variable, Y is one variable. Let us assume, so what we can call it as a demand, let us assume, and this is called price. So whenever demand is more, price also more. And whenever demand is less, price also less. This is called correlation. X and Y are correlated. Why? So there is a functional relationship between these two variables. That's why we can call it as both are correlated. If there is no relation, let us assume X is one variable. Let us assume Y is one variable. Let us assume number of admissions in Vishnu Engineering College. Let us assume rainfall in Bangalore. Whether rainfall increases, number of admissions increases in Vishnu Engineering College? No. Whether rainfall decreases in Bangalore, whether admissions will decrease in Vishnu Engineering College? No. There is no correlation. We can call it as both are uncorrelated. There is no relation between these two random variables. That's why we can call it as an uncorrelation between these two random variables, or we can call it as uncorrelated. But basically, when you have a correlation between X and Y, how to measure? Because when you have a data, let us assume 1, 2, 3, some numerical data, we have values for X, Y, Z. We have a data set for X and Y. And how to measure there is a correlation between these two random variables or these two variables or these two attributes. So for that, correlation coefficient comes to the picture. So theoretically, it's very clear. When the price is, demand is more, price increases. When demand is less, price decreases, like that. But when you come to the mathematically, if you have a data set like this, how to measure the correlation between these two variables, or how to measure the correlation between these two attributes, or maybe what we can call it as a futures. So for that correlation coefficient, we have to use. So that means here why it comes to the picture for a recommendation system. I'm talking about collaborative filtering. I have already explained about what is collaborative filtering process. There we are looking for basically similarity between these two users. When you are looking for similarity between these two users, or we can call it as if we are looking for correlation between these two users, we have to use correlation coefficient. So by using correlation coefficient measures, we can see the similarity between these two users. Based on that, we can decide how much both are correlated. Based on that, we can go for a rating prediction followed by recommendation. Of course, so many other models also available. I already said we can go for naive-Bayes classifier, KNN classifier, and decision tree, random forest, Bayes, etc. Even matrix factorization. But that models will take more time to explain. That's why I'm taking simple statistical measure by using that, how the recommendation system will work, followed by what type of movies or products are recommending to the customers. So here the basic formula is, this is called covariance of two random variables, that is called CO of xy divided by standard deviation of x, standard deviation of y. So by using that, we can look for similarity between these two measures or these two variables. Variables means here, let us assume user 1, user 2. U1 is one user, U2 is one user. So here whatever formula given here. So x bar means mean of, let us assume x, y. X is one user, y is one user, and x bar means mean of x user, y bar means mean of y user, xi means the values of x, values of y. So this is standard deviation of one user, this is standard deviation of other user or customer. So the whatever formula I have discussed in the previous slide for correlation coefficient between two random variables, I can convert it into users. A is one user, B is one user. That is called similarity between A, B. So as per the base paper I have shown published in IEEE Access. So I'm taking similarity between two users. Based on that, how the movies or products are going to recommend to the users. So A is one user, B is one user. Here RAP means rating of user A for item P. What does it mean? So this is P product, this is A, this is B. So this is called RAP. Let us assume the rating given for product is 4 letters. This is called RAP. This is RBP. So that I have already shown the data set also. So these are the ratings. RAP means rating of user A given to product B, or BP means rating of user B given to product B. That's the meaning of RBP. RA bar means average value of customer A. RB bar means average value of customer B. This is standard deviation. Like that, we have to collect all the values. Based on that, we can find the similarity. Based on that, we can identify how much two users are similar. So I will show one simple example for recommendation system in healthcare domain. So if you want complete details, you can go through this paper published in Springer. So how the recommendation system will help to the healthcare domain. So we can go for food recommendation and drug. Food recommendation, what does it mean? So based on the disease, let us assume a person having COVID-19, what type of foods we have to take, that recommendation will get automatically. Maybe a cancerous person, what type of food he has to take morning, afternoon, or maybe night. So such type of recommendation it will do. And drug recommendation, what type of tablets you have to use based on the disease. And physical activities, what type of physical activities you have to do morning or evening based on the disease. And healthcare professionals recommendation, suppose a person having COVID-19, so the doctors, those who are expert in the diagnosis of COVID-19 will get recommendation. Maybe a person having cancer, maybe you will get recommendation of the doctor who are expert in the cancer. So like that, we'll get healthcare professionals recommendation based on this recommendation engine. So now I will show one simple example that is published in the paper, what I have shown in the base paper. So let us assume we have a simple data set. So this is age of the customer or maybe patient, insulin level, glucose level, and BMI, body mass index, and BP level, and thickness means the fat level. So these are the 4 patients data already available in the database. So this is the active patients. Leave it this one. First row you can leave it. So this is a training data set. So we have 4 patients. All the 4 patients data we have attributes, or we can call it as a symptoms. So insulin, or maybe age, what is the age factor, what is the insulin, what is glucose, all the attributes, maybe all the columns or all the field values are available. Now this is the new person, active person. We can call it as a Tom. He is the active person. He visited the is having age 25 and insulin level, all those things. Now the recommendation system, what type of prescription is going to recommend to active patient Tom? So there is no doctor, nothing, but the Tom or maybe active patient will get recommendation of the prescription. So how the machine learning plays a vital role. So based on that, what type of recommendation is going to receive, followed by what further action or further diagnosis. So here basically I already said we are looking for collaborative filtering process. There we are looking for similarity. What we have to do here, first we have to see the similarity between patient 1 and Tom. So by using correlation coefficient. After that we have to look for similarity between patient 2 Tom. After that we have to look for similarity between patient 3 and Tom. After that, we have to look for similarity between patient 4 and Tom. Now, how to calculate similarity? I have already given the formula. So correlation coefficient, or maybe you can apply cosine similarity, or you can go for any classifiers. So, but I'm giving simple measure because of time factor. So when you use correlation coefficient, we can find the similarity between these two users. So you can see here, the similarity between Tom and patient 1 is 0.86, 86%. That means patient 1 and Tom similarity is 86%. How to calculate the similarity? I have already given the formula, covariance of xy given by standard deviation of x, standard deviation of y. So x indicates Tom, y indicates patient 1. So all the numeric values are available, all the measures are available. I mean, all the attribute values are available. Just you can put in this formula, so you'll get the correlation coefficient. We can call it as a similarity between Tom and patient 1. How much we got? 0.86. Next, we have to look for the similarity between Tom and patient 2. So here, try to understand the concept. So similarity between x comma I. X is fixed provided that I equal to 1, 2, 3, 4. So this is a basic idea. This is a simple mathematical equation. So we have to find similarity between x and 1. We have to find similarity between x and 2. We have to find similarity between x and 3. We have to find the similarity between x and 4. So x is the active patient. He is looking for the recommendation of the prescription, that we can call it as a, what type of tablets he has to use. That is called prescription. So now we have to find the similarity between x with all the historical data users. That means already these users data is available in the data set. Now we calculated the similarity between Tom and patient 2 is 51%. Similarly, the similarity between Tom and patient 3 is 0.49. Similarly, the similarity between Tom and patient 4 is 0.04. That means 4%. The similarity, finally, the similarity is done. That means we have calculated the similarities by using the correlation coefficient, or you can use any other measures also fine, like cosine similarity, etc. Now, finally, when you see the similarity, so Tom and patient 1 having highest similarity when compared to rest of the similarity values. So 51 less than 86, 49 less than 86, 4% less than 86%. So which indicates that Tom and patient 1 are more correlated. That means more similar. I have already shown. So X, A and B users watched Crack and KGF. Both are similar users. Based on that, whatever movie watched by A, it will recommend to B. Similarly, here also, when you come to the healthcare domain, so whatever symptoms patient 1 having similar symptoms Tom also. That means here you can see insulin level 25.9, here 25.4. Here glucose 166, here 86. A little bit gap is there. So here to 25.8, 27. So here almost same. BP level, fat level also almost same. So that's why we are getting highest similarity. So now based on that, what recommendation will do? So whatever prescription given to Tom, patient 1, same thing will recommend to Tom also. That means already prescription is available in the data set. So patient and prescription, all this is the historical data. So whatever prescription is available for patient 1, same thing will recommend to Tom. Now you can go to pharmacy and you can take that medicines or maybe drugs, whatever it may be given in the prescription. So this is the way it will recommend prescription. A similar way we can look for healthcare professionals. Similar way we can look for food recommendation. Similar way we can look for exercise recommendation in the healthcare domain. So finally, whatever prescription given to patient 1, same thing will recommend to Tom also. Now we can see the final conclusion. So patient Tom, this is a prescription sorry, this is a patient one prescription. So same thing will recommend to term. RX means in medical terminology prescription. So whatever prescription patient one having, maybe here you can see 1 tab and 650 mg tab, something is there. We don't know much about medical terminology. So my intention is, so this is a prescription for patient one, same thing will recommend to term. So this is a way the collaborative filtering algorithms will work for recommendation of the items or products or movies to the customers. Here we are looking for basically similarity between these two users or maybe these two patients. Based on that, it will recommend automatically. We can save the time, we can save the money, and no need to visit doctor. Like that, we have huge benefits. And as a customer, I am also happy. As a patient, here we are talking about healthcare domain. At the same time, the recommendation system application, there the owners also will get more revenue. Even if we take a healthcare professionals recommendation, so we have apps like that. So when you type the symptoms, let us assume if you type headache, or maybe if we click here cough, maybe headache, fever, etc., I will get recommendation of the doctor near to you. So let us assume I'm staying in Whitefield. If I type the symptoms, automatically I'll get recommendation of the doctor near Whitefield area. Based on that, I can consult immediately. Otherwise, it won't recommend the doctor far from the Whitefield. Like let us assume I'm searching doctor near to my area. Recommendation system won't recommend any doctor in Hyderabad or Vijayawada like that. So it will recommend near to you, and based on that you can consult. Whether you are going to consult or left is left to you. But the recommendation system objective is to recommend doctor based on your symptoms. After that, you can go and doctor. Based on that, you will get proper treatment or maybe diagnosis. Hello, sir. Hello.
Yes, sir.
Sir, still how much time is left, sir? Can I take 10 more minutes, sir?
Yes, sir. Yes, sir.
No issue. No?
No issue, sir. You can take.
Yeah, it's interesting only. I won't make anyone feel bored.
Yes, sir.
Yeah. So I'm showing one more product recommendation example directly. I'm not going to explain mathematical models, all those things. I already said I need minimum 3 to 4 hours for completing this recommendation only. Just I'm rushing out this one more product recommendation. So this is the utility matrix. Actual data set we have, I have already shown from one of the movie data set that is called Movie Glance, some website, or maybe you can take any public repository also. This is the utility matrix. We have various users and various items. Here some rating is missing. What the collaborative filtering process will do, we have to calculate the similarity between DAY4 with all the users. So I have calculated, no time to explain these things in detail, but of course everyone knows how to find the correlation coefficient between two random variables. Same formulas only we are applying. So we have to find the correlation coefficient between DAY4 to Gopi and DAY4 to Sachin, because DAY4 rating prediction we have to do, and DAY4 to Vishnu. All the rating, all the correlation coefficient values we have calculated here. Now you can see here, the correlation coefficient between DAY4 and Gopi is 85%, 0.85, that is called similarity. And DAY4 and Sachin 70%, that is the similarity. And DAY4 and Vishnu, negative means we can take it as uncorrelated. I already gave example also, rainfall in Bangalore and number of admissions in Vishnu college like that. So no need to consider. Negative means 0% similarity. Yeah, please mute, madam.
Yes, sir. Please proceed.
So we have calculated the similarity between DAY4 with other customers or other users. So we found that the highest similarity is DAY4 and Gopi. This is the highest similarity, 85% similarity when compared to the rest of the users. What the recommendation system will do, whatever rating given by Gopi to item 5, same rating prediction is going to consider here. That means rating prediction is 3. So this is the simple collaborative filtering process by using correlation coefficient or cosine similarity. Now finally we done rating prediction is 3. So once again, I will explain. We have calculated the correlation coefficient between DAY4 to Gopi, DAY4 to Sachin, DAY4 to Vishnu. When you see highest correlation coefficient is 0.85, 85%. That is the highest similarity when compared to the rest of the values. So that means DAY4 and Gopi are more similar. That's why whatever rating given by Gopi to item 5, same thing we are going to consider. That is the rating prediction for DAY4 to item 5. But I already said the minimum rating should be 4 or 5 for recommendation. So as per that, so the recommendation of item 5 is not going to happen for Daivic because the rating is 3. So my threshold value is 4, minimum 4. If the rating prediction is 4 or more than or equal to 4, then it will recommend. Otherwise, not going to recommend. So if the rating prediction is less than 4, it is not going to recommend. Suppose if you want to make it as 3, fine. If you want to make it as a threshold is 3 for recommendation of the movies, then you can item 5 will recommend to Daivic. But as a developer, I fixed 4 is the threshold value. Maybe if you want to insist 3, maybe item 5 will recommend to Daivic. But in our case, I am assuming minimum rating is 4. That's why item 5 is not going to recommend to Daivic. So this is the way we have to look for similarity between users based on that items or maybe products, or it may be movies, or it may be a healthcare domain. We can call it as a prescription, will recommend to the other users. So this is the way we have to look for similarity. I given only one simple statistical measures, but we can go for a Bayes and a classifier. We can go for other classifiers also for rating prediction as a categorical values. So this I will skip. A quiz I mentioned. Yeah, you can see here we have these are the ratings missing here. Vishnu to movie 1, Vishnu to movie 3, Vishnu to movie 4 ratings are missing. So now my problem is which movies we are going to recommend to Vishnu. So I'm going to give answer because no time to give to the participants. So basically we have to calculate similarity between Vishnu to Daivic 32%, Ramesh 73%, Somu 21%. So we have a huge correlation between Vishnu and Ramesh, and whatever rating given by Ramesh to movie 1, you can copy paste here. Whatever rating given by Ramesh to movie 3, copy paste here. Whatever rating given by Ramesh to movie 4, copy paste here. Now movie 4 will recommend, movie 1 will recommend, movie 3 is not going to recommend because of very low rating. So that means 4, 5 ratings are very excellent ratings. That's why these 2 movies are going to recommend to Vishnu. So this is a simple example, one more example for movie recommendation. Even we can apply Navi-based classifier also for recommendation of the movies or products by using collaborative filtering process. How the Navi-based filtering we are going to apply here? What we are going to do here? We have to find. So we have rating scale is 1 to 5. We have to find probability of y equal to 1, rating 1 given x. X indicates the ratings given by the user previous other items. Similarly, we have to find the probability of rating 2 given the ratings given by the user for other items previously. Like that, we have to find all the ratings. So all the ratings probability we have to find. Here, let us assume 0.1. Here, let us assume 0.4. Here, let us assume 0.6. Maybe a rating 4 is 0.01. Let us assume 0.05. Out of all the ratings, rating 1 probability is 0.1, rating 2 probability is 0.4, like that. So highest probability is maximum probability is 0.6. As per the Bayesian classifier, what is the Bayesian classifier? The prediction y equal to, or classification y equal to argmax probability of y given x. So what is the maximum value? 0.6. What is arg? Rating 3. Therefore, the rating prediction is 3. So maybe if you want in detailed explanation, you can go through this paper, a collaborative filtering approach based on the Navi-based classifier. So even for this also, I used to take 2 hours. What is Navi-based classifier and how it will applicable to the recommendation, or maybe healthcare, etc. application, or maybe machine learning application, all those things. Just I'm giving the brief glance. If you want complete details, you can go through this paper. Because of time factor, I'm not explaining, but I'm showing the path. So basically, we have to find all the probabilities rating, and we have to look for maximum rating. Probability, that is nothing but rating. So this evaluation I will skip. So if you want to evaluate, so please mute your voice, sir. Sir, please mute it, sir. Yes.
Users, please mute yourself.
Somasekar, sir, please unmute yourself, sir, please. Somasekar, sir, please unmute yourself, sir.
Yeah. Now, is it clear, sir?
Yes, yes, it is clear, sir. Clear, please.
I think automatically muted. So when you come to the evaluation matrix, we have, this is a common evaluation, maybe for for regression analysis also we can do MSE or root mean square error. So here the basic idea is, so when you go for testing phase, we have to evaluate. So PA is nothing but predicted rating, RA is nothing but actual rating. So that is already available in the data set. N indicates number of users or number of customers. So we have to find the RMSE value. Less RMSE value indicates the more accurate model. That model is the more accurate for recommendation system. Based on that, we can deploy to the application. So you can see simple example. So we have a user ID, movie ID, rating, and prediction. So actual rating is 5, but rating prediction by any one of the classifier or any one of the statistical measure is 4.5. Here 4, here 5. Finally, when you make the different whole square, why we have to make different whole square? If you are not making whole square, sometimes negative becomes, when you make sum of negative positive of all the prediction and actual ratings, will get 0. It does not mean it's more accurate. Because of that reason, we have to make a square. Negative square means we'll get positive. Based on that, we can make a total, we'll get positive value. And here RMSE value is square root of 5.6 by 10. 10 indicates number of users here, N, so that we got 0.75. So we have to do with so many other models, then only we can decide which one is the least RMSE, that is the best model to deploy to the application. For example, if we have a movie data set and I have to apply various machine learning models. Yeah, fine. Yeah. So we have a movie data set. Now, which model I have to deploy to the movie data set recommendation? So for that, let us assume we have to calculate RMSE for PCC, Pearson correlation coefficient. I got 0.57. Why I'm showing this one is just for research point of view, we have to do all those things. We have to evaluate, we have to compare. Based on that, we can decide which is the best model for recommendation of the movies. PCC, let us assume I got 0.57 RMSE value, and probabilistic model I got 0.31 RMSE value. And cosine similarity, this is also very simple measure, that is 0.45, and matrix factorization or latent factorization 0.43. Out of all the 4 models, which is the least RMSE value probabilistic model, that is called Bayesian classifier, hence we can deploy to the application. So probabilistic model we can consider for recommendation of the movies, so that we can deploy to the application. So this is a way we can evaluate. Based on that, we can decide which model is the best suitable to the application. If you want to look for further enhancement of the recommendation system, I will show some of the resources. Based on that, we can enhance or you can explore, because this is one of the very emerging research area also nowadays, because of huge number of applications I have already listed in the initial stage only. Recommendation system with Python, you can go through this you can download also open source. You can find even Python code also for implementation. And mathematics for machine learning. Of course, without mathematics, we can't do any one of the models in machine learning. All the models purely depends on mathematics. So if we are little bit weak in mathematics, try to go through the mathematics. Then only will be good in machine learning or data science or AI, etc. Without mathematics, it is difficult to become a specialist in machine learning or data science. So that's why maybe for beginners, if you are looking for more details about mathematics like probability, statistics, calculus, linear algebra, etc., we can go through this textbook. And if you are looking for still some of the research directions, you can go through recommendation systems, principles, methods, etc. That is published in Elsevier journal. You can go through this. And maybe if you are looking for data sets, you can go through UCA Machine Learning Repository. There you can find benchmark data sets for your research point of view. So that was my talk on recommendation system. I started recommendation system definition, applications, and case studies and data sets, evaluation, and various resources, all those things. I have shown the complete path for recommendation. Hope you understood. Whenever you are getting recommendation of the videos, etc., now onwards, you'll remember this session surely. So if you have any queries, I'm happy to answer your queries or any other discussion also. Thank you. Please, you can type your
Participants, you can unmute yourself and you can ask your queries to this professor.
or you can send your queries to my mail ID also. Here I am.
Yeah, many of the NITs, they are now working with recommendation systems.
Yes, sir. Yes, sir. Correct.
NIT Durgapur now in the last
Correct,
year.
Even NIT Warangal also.
So there, most of the people are working in this particularly on recommendation systems.
Yeah. Because we can get huge funding also, sir, for this. If you go for Microsoft or maybe any R&Ds, we'll get funding also.
Yes.
Any queries, you can type your query in the chat box also. I will see.
Even though the presentation is 40 minutes, but there is a lot of depth in the presentation, sir. Yeah, how much time you have taken to prepare the slides?
Yeah, these slides, one slide, sometimes I used to take even 30 minutes also, sir.
Sometimes.
We need a lot of time for making
The presentation. Yes, yes.
no, so far I completed only recommendation system, only more than 30 talks in countries.
Okay, okay. So you are well versed now with recommendation systems.
Yes,
and your
but I have
publications are also into this
both machine learning and image processing, sir.
image processing. So your image processing is on MATLAB or in Python, sir? Actually,
MATLAB, sir.
MATLAB itself.
Any queries, please type in chat box also fine.
Participants, you can unmute yourself and you can interact with our professor, please. Raja, we can conclude, sir, then.
Yes, sir.
Okay,
Yes.
Thank you.
Thank you so much, Dr. Somasekar garu, for giving such an innovative presentation on recommendation systems in e-commerce and streaming. Thank you, sir. Thank you so much for sharing valuable insight readings, e-commerce and streaming online websites. Thank you, sir. Thank you so much, sir.
Yeah, thank you, sir. Yeah, thank you, Kiran, sir, for opportunity. Thank you, sir.
Thank you, sir. Have a nice day.
Yeah, thank you, sir.
Let us continue this collaborations on Somasekar.
Sure, sir. Sure, sir. Always welcome, sir.
Thank you. Thank you.
Thanks.
All the participants present over here, stay connected. The next session will be started in few minutes.